After design, the second most important factor in the maintenance and operation of these types of devices is maintenance. These devices need to be maintained on a regular basis, hopefully quarterly, so that they can always perform at their peak capability.
Our job as inspectors for the District Department of the Environment is to go around and look at these devices and make sure that the owners are doing their job and living up to their maintenance responsibilities for keeping the device in good working order. First order of maintenance would be to remove all of the trash that's accumulated in the facility over the past year since it's been maintained last time. The good news is all of this trash and debris and sediment and grit that would have normally gone into the river are all trapped right here at this bioretention area in the inlet as well as in the bed area. One of the maintenance issues with bioretention areas are the inlets. If they're not clear and cleaned out regularly, then it presents a problem because they clog up and the water bypasses. A little area that's starting to be cut away due to a concentrated flow of stormwater that's come down the hill and hit the curb and run into the curb cut inlet as it's designed to do. But once it's gotten to the stoneware, the concentrated flow of water has begun to cut a rill right through the bank of the stormwater pond. So therefore, it would need to be addressed by either creating a larger, more robust stoneware or backfilling the area, or probably both. This is some of the bad things that can happen at bioretention cells. We have a problem here with earth slippage where the banks are somewhat steep, and this is one of the problems that can occur with bioretention on some sites. And as a result, we have a large slippage here and cut of the soil. And the soil is kind of an unstable soil. So we're going to have to rebuild it. That ensures that it doesn't continue to cut and fill in the bottom part of the bed. Also, a thing would be to remove volunteer weeds like this locust tree that started to grow, and to cut off the overgrown plants that were planted in initially.
Now these plants have been here for a couple of years now, and you can see they're actually in very good shape. There's not a lot of dieback, lots of good buds on the stems. But what we want to do is check and just see how the roots are growing and make sure they're not bound up or there's too much clay around the root system that would prevent them from spreading out and really growing well. So what we do is just dig a very small hole around the base of the roots and take a look and see how the roots are coming out along the plant. You can see here they're very fibrous and they're really expanding out from where the root ball would be. So that really shows that the plants are really growing nicely and have a good chance of long-term survival.
Rain from this large apartment complex drained directly to sound bioretention on this location. There were three problems on the site. First, the under drain was completely clogged, unable to drain water adequately. Two, all the plant materials were dead and they needed to be replaced. Three, inadequate mulch and they had to be replaced.
We're taking care of one of their bioretention ponds. What we've done to start with is opened up the overgrown vegetation that had basically taken over the bottom of the pond here, leaving the desirable natural plant material, and most importantly, opening up the inflow feature from storm drain into the pond where the bioretention pond does its job. You can see how the silt has built up around the former existing rock bed here. That's all going to be cleaned out, and then we're going to be adding additional stone to help do two things. Number one, convey the water in the direction we want it to go, and number two, deflect the force of the water to where it disperses more effectively throughout the pond bottom. You can see the amount of trash. Almost all of this has washed in as just through the course of natural runoff through many of the summer storms we've had over the last 2 months. What we're doing now is we're going to be establishing a stone weir or a dam wall, basically to prevent materials from infiltrating into the storm water system but allowing the water to pass through. The first step, of course, is to clear the unwanted vegetation, and then we lay this filter fabric, polyester fabric, underneath the stone to act as a soil and material separator. Then we lay the first row of stones to establish the dam wall. At that point, we pull the fabric across the stones. What this does effectively is it will establish a filtration barrier on the outer edge that also keeps the stones from clogging as time goes on with some of the different materials that may come through, whether it's soils or mulch or trash. Then the next step will be to establish the second row of stones directly behind the first. What that does is it helps to secure the fabric in place and add strength to the entire stone weir, and then they'll put a third row on top of the first two, giving height, adding additional weight for reinforcement, and basically completing the stone weir wall. What we're doing here is basically continuing to knock down the unwanted vegetation, but leaving desirable plant material in place. We take out most of the items that are actually seed grown, such as some of these field weeds and the clovers most people are familiar with. Although it's very attractive, the root structure just isn't solid enough in the event of an extra long cold and wet spring. The root structure doesn't tend to hold the soil as well as perennial plant materials and woody plants. Therefore, we're going to be introducing other woody plants into these open spaces. Here's an example of a plant that we're leaving, very desirable. Winter hardy hibiscus, the Lord Baltimore variety, will actually get 6 to 8 feet tall, very large, very attractive red flowers, and just thrives in areas like this that tend to be flooded and wet. You can also see on this side some of the larger ornamental grasses that are being left in place. Again, thriving in this kind of environment. You can see how well they're doing right now. And in the back, some of the larger, woodier plants, from the native roses all the way to the large bayberries. Those are all staying in place as well. Once again, being able to thrive in wet and dry conditions depending on what happens. The plants we'll be introducing here will all be also the same type of a plant material that can handle heavily wet conditions for extended periods of time, as well as drought in the event of the conditions as we had in 2007 of extended drought. The uncut area here is being left for a reason. We always like to leave a buffer around the edges. This area ranges anywhere from 4 to 6 feet thick and will run the perimeter of the fence. It helps to establish the soils in this area, keep them a little more natural, not just in appearance, but also in retention capabilities, and also helps to keep the water flow in the central areas of the pond where it's wanted to be, where it can then seep down into the subsurface drainage structure and move toward the outflows as we were looking at before.
Regular maintenance is critical to ensure that any stormwater management facility functions properly. The District Department of the Environment provides educational and inspection services to those responsible for maintaining stormwater management facilities. Timely and proper maintenance helps protect the health and safety of district residents and our local environment. The primary maintenance requirement for permeable pavers is to clean the surface drainage voids. Fine debris accumulates in the drainage openings and reduces the pavement's flow capacity. It is natural for clogging to occur over time, but routine maintenance reduces this problem. Inspection of the site should occur monthly for the first few months after construction. Then, inspections can occur on an annual basis, preferably after rain events when clogging will be obvious. Conventional street sweepers equipped with vacuums, water, and brushes can be used to restore permeability. If necessary, additional aggregate fill material consisting of clean gravel can be added to replace lost material. Potholes and cracks can be filled with patching mixes, and clogging of porous concrete may be fixed by drilling approximately 1/2 inch holes every few feet. Damaged interlocking pavement blocks can be replaced. Actively sweeping the site's drainage area will help to prolong the life of the pavement. You can increase the longevity of your permeable pavement system by following a maintenance schedule of vacuum sweeping, high-pressure washing, and limiting the use of de-icing chemicals and sand, and implementing a stringent sediment control plan for the drainage area of your permeable pavement field. For further information regarding low-impact development practices or the RiverSmart Homes program, please contact the District Department of the Environment at 202-535-2240, Monday through Friday between the hours of 8 a.m. and 4:45 p.m. or visit us online at green.dc.gov.